Welcome guys. In this video, we're going to be solving this very problem. I'm Dr. Avitech, and on this channel, we deal with engineering and mathematics problems. So let us get started. Remember to hit the subscribe button, like this video, and share it across to your classmates. To get started with, if you've been following me, you do notice that I try to sketch my functions, but there's really no use for me to do that here because it's not going to help me at all. So I am not going to be sketching that because it's not going to help me. Now, I would have said it would have helped me because s squared is even, so it helped me out. But because this very interval is not symmetric, I can't use it either. So let's just proceed to finding the Fourier series of that. So the first thing we're going to find is a0. So a0 is 1 over pi integral from minus pi to pi of f of x dx. Now, also, if you've been following me, you'll notice that whenever I want to do a0, I just find the area under the curve. So, but the thing is, in this case, I can't do that because s squared is not forming a shape. I know it's forming a parabola. So the best way to find the area is to just use an integral. So in this case, I am not going to be finding, I'm not going to be graphing or anything. I am just going to, what's it called? Use the integral. So this will be 1 over pi integral from, the thing is, minus pi to pi is the interval, but you can notice that minus pi to pi was broken down into minus pi to 0 and 0 to pi. So what I have to do is to say I have the integral from minus pi to 0, from minus pi to 0, then the function from minus pi to 0 was 0, this 0 dx, plus the integral from 0 to pi, and then the function there was s squared dx. Yeah. But the thing is, this one will be 0. So just take it out. That will be 0. So what will be left will become this. So this is 1 over pi. Then we're going to have, let's integrate s squared. If we integrate s squared, we're going to have s cubed all over 3. And then this is from 0 to pi. Now, how did I get the s cubed? Remember that if you have s squared, when you're integrating, you need to say 2 plus 1 over 2 plus 1. So that was what I did. 2 plus 1 is 3. So that's what I have that. Okay, this over 3 can come outside. So this becomes 1 over 3 pi. The one will be left will be s cubed. That's what will be left from 0 to pi. So this will be 1 over 3 pi into, now let's put in our limits. So the upper limit goes first. So this will be pi cubed minus 0 cubed. So when we put in our limits, that's what we're going to be having. Now, but the thing is, 0 cubed is still 0 cubed. So this will just be 1 over 3 pi times pi cubed. Now, the pi here can cancel this pi cubed to give you pi squared. So the final answer for this will be pi squared all over 3. All over 3. Yeah, just all over 3. Just all over 3. Okay. So the next part is to find a sub n. So that's what I have. So the next part is to find a sub n. So a sub n would be, let's see, 1 over pi, integral from minus pi to pi of f of x cos nx dx. So this is 1 over pi. And then we have this guy, integral from. Now, remember that we're going to break it the way we did here. But the thing is, since this part will always give me 0, since one part of the function is 0, let me just throw that away. Let me only use this one. This will be from 0 to pi. F of s is s squared cos nx dx. Now, what I did is actually logical. Since this part is 0, instead of going through the stress of writing it, when it's to give me 0. So don't write it again. Just write only this one. But this time around, remember that it's multiplied by the cosine. All right, so let's integrate this. We're going to be using integration by parts, but the thing is, there's a shorter way to do that. So what I would do is to say this is 1 over pi, open up a bracket, write your x squared. Then differentiate s squared until you get 0. So s squared, when you differentiate s squared, you have 2x. When you differentiate 2x, you will have 2. When you differentiate 2, you will get 0, but there's no need for us to write that. There's no need. Now this is cosine nx. We're going to be integrating the cosine nx. To integrate cos nx, we're going to have sine nx over n. Remember that to integrate a trigonometric function, you must divide by the derivative of this angle nx. So the angle nx, when you differentiate this, you're going to have n. So you must divide by that derivative. Now this right here, this whole bracket here, you also need to integrate it again. Integrate this bracket again. Now for the sine, this sine nx, this will give you minus cos. Because when you integrate sine, you will get minus cos. Then put your angle nx. And do not forget that if you differentiate the angle nx, you're going to have n. You're going to have n. So the n will come and make this n that has been here before to give us an n squared. So I kind of believe you're getting the picture. And then this expression here right now, integrate this whole expression again. This whole expression again. So this will be minus. When you integrate cosine, you have sine. So this is sine nx over. Now from the nx, if you differentiate the nx, you're going to have n. But that n will come and make this n squared that has been here. So that's what we're making it n cubed. And then the sign will be plus, minus, plus. It follows that pattern. And then put in your limits as 0 to pi. Now let's simplify this whole expression. So this will be 1 over pi. Then we're going to be having s squared sine nx over n. Minus times minus here will give me plus 2x cos nx over n squared. And then plus times minus, minus 2 sine nx over n cubed. And then this is from 0 to pi. Okay, now if you've been following my videos, you kind of know that I've said sine is a very funny function where you have 0 and pi. Sine 0 is 0. Sine n pi is 0. Sine of minus n pi is 0. So it's basically 0 almost everywhere. It's basically 0 almost everywhere. So this guy here would be 0. This guy here would also be 0. So the only useful guy is this one at the middle. Okay. Now, since this is the only useful guy, what is the constant term here? 2 over n squared is a constant term. Remember that you are integrating with respect to x. So anything that doesn't have x is a constant. So this is 2 over n squared. I'm going to bring it outside. So we're going to be having 2 over n squared pi. Because 1 times 2 is 2. Pi times n squared pi. And then close this up. What will be remaining will be s cos nx. And this is from 0 to pi. Beautiful. Very, very beautiful. So this will be 2 divided by n squared pi. Now let us, anywhere we see s, we're going to be putting pi. So this will be pi cos n pi. Yeah, pi cos n pi. And then minus, anywhere you see s the second time, we're going to be putting 0. So this will be 0 cos 0. But the thing is, 0 times anything is 0. So this guy here is gone. It's 0. So what's remaining is this pi cos n pi. So this will be 2 over n squared pi times pi. Now what is cos n pi? It's a special value. Cos n pi is minus 1 all to the power of n. So that's minus 1 all to the power of n. So this pi will cancel out this pi. So what will be remaining will become 2 over n squared with minus 1 to the power of n. And the value of this is very, very easy. Minus 1 to the power of n is negative when n is odd. Minus 1 to the power of n is positive when n is even. So I just want to leave it like this. There's no need to determine if it's even or odd. Yeah, I think I'm just going to be putting my values here. Just going to be putting my values there. So first of all, a naught is pi squared over 3. Then a sub n is 2 into minus 1 to the power of n over n squared. Okay, so I'm just gonna leave that. All right, now let us find b sub n. But I have a feeling that b sub n, yes, let's see. I kind of have a feeling that it might be 0. I don't know, but let's see. So let me solve this guy. But because of this 0, that's why I can't really tell. Because of that. Well, let's see. It's not difficult to solve. It's easy. Sometimes I'm kind of happy if my function is minus pi to pi and there's a 0. I kind of hate when my function has pi over 2. I kind of hate it because that way sine would then be useful because sine would no longer be 0 when it's pi over 2. So let's find b sub n. So b sub n is 1 over pi, integral from minus pi to pi of f of x sine nx dx. So that's my b sub n. But the thing is, the minus pi to pi will be broken down into minus pi to 0 and 0 to pi. But the only useful part will be the 0 to pi because that's where you have something meaningful. The other one you have 0 and 0 is not meaningful. So you're only going to be using the s squared. So this is 1 over pi, integral from 0 to pi of s squared sine nx dx. So that's what we have. This is what we have. Okay. And this is where we apply our integration by parts. Integration by parts here. So let's use our procedure again, our short form, the better way. So this is 1 over pi, open up a bracket. This s squared, I'm going to write s squared. So this is s squared. Then differentiate s squared until you get 0. So differentiate s squared, you're going to have 2x. Differentiate 2x, you're going to have 2. Now, this expression here, sine nx, you need to integrate this. So integrate sine, you get minus cos. Then you put your nx. Let me move my 2x a little bit far. Hold on. 2x and 2. So this, when you integrate sine, you're going to get minus cos. That's minus cosine nx. Now, you must divide by the derivative of nx. So differentiate nx, you're going to have n. That's for that first part. Okay. Next, this whole bracket here, you need to integrate it again. To integrate this bracket again, first of all, this is a minus. Integrate cos, you will have sine nx. Now, you must divide by the derivative of the angle. So this nx, when you differentiate the nx, you're going to have n. But remember that there was an n before. So when the two n's meet, that will be n squared. Now, this expression here, you need to integrate it again. You need to integrate this expression again. So this will be, there's a minus here. Integrate the sign, you're going to have minus cosine. So that's two minuses. And then you put your nx. Now remember that you must differentiate the angle. You must differentiate this angle nx. You must differentiate the angle nx. So when you differentiate this nx, you're going to have n. But the n will come and make this n here. So that will now be giving us n cubed. And then this is plus, minus, plus. And then you put your limits 0 to pi. Okay, so let's simplify our expression. So this will be 1 over pi, then minus times plus is minus. So this is minus s squared cos nx divided by n. Yep. Minus times minus will give me plus. So this is plus 2x sine nx divided by n squared. This here is plus. So everything here will just be plus. So this is plus 2 cos nx divided by n cubed. And this is from 0 to pi. All right. So let's proceed. Now we know that sine nx will give us 0, just like the previous example. So I could just take this out. So give me 0. So no need for me to go through that again. So the only useful guys will be these two. It's going to become these two guys. These are the two useful guys. So now let's proceed. Let us put in our pi and 0. But before doing that, I want to interchange this. Why do I want to interchange? This one is negative. This one is negative. So I kind of want to write it. I want to interchange them. It's still the same thing. Or let me leave it like this because sometimes interchanging might confuse some person. So let me leave it like this. So I'm going to go with this one first. Let me put in my pi and 0. Let me put in my pi and 0 for this one. So this will be minus pi squared cos n pi over n. So this is the first one. When you put in pi, anywhere you see s, when you put x, this is x, right? So when you put in your pi here, you're going to have minus pi squared cos n pi over n. Then for your lower limit, x will be 0. But let us save some time here. If this is x and you put 0 here, 0 times cos ns will be 0. So this guy is gone. This guy is gone. Because when you put this x right here, when you put in your 0 here, minus 0 times this will give me 0. So that one is gone. So this is gone. So let's go to this one. Plus 2 cos, let's put in our pi here, the upper limit. This will be n pi over n cubed for this very one. And then minus, the next one, x will be 0. So this will be 2 cos 0 over n cubed. All right. All right. So this will be 1 over pi. We're going to be having minus pi squared. Cos n pi is minus 1 to the power of n. Then divided by n. Plus 2. Cos n pi again is minus 1 to the power of n. Divided by n cubed. And then minus. Cos 0 is 1. Cos 0 is 1. So this will just be 2 over n cubed. Yep, as you can see, this is actually bulky. And it's not 0. This is bulky. Okay, but there's something we can do. There is. So this will be 1 over pi. I'm going to leave this one like this. So this will be minus pi squared minus 1 to the power of n over n. Now, if you look at just these two, guys, just these two, they have 2 over n cubed common. 2 over n cubed common. So this will be plus 2 over n cubed into minus 1 to the power of n minus 1. I'm going to explain that factorization. Okay, so what I did is, I have 2 over n cubed, 2 over, remember that this can be times 1, right? So when you remove the 2 over n cubed, since 2 over n cubed is here and 2 over n cubed, you can factorize it out. So what will be remaining will become minus 1 to the power of n minus this very one. So that's what will be remaining. The reason I did this is so that we can get the even and odd guys. So when n is, I believe you kind of know how this behaves by now because we've done examples where this is given to us. So when n is, let me see, it's when n is even, that's when it becomes 0. So when n is even, we've done this previously, so I might not really take up time to explain it. So minus 1 to the power of 2. When you square this number, minus 1 squared is 1. 1 minus 1 is 0. 1 minus 1 is 0. So everything here, 0 times 2 over n cubed, that's 0. So every single thing here is now 0. I explained this in earlier examples. You could actually work it out if you wish. For this bracket, because we're trying to find out how this behaves. So for this part, this is 0 when n is even. So this means that your b sub n would then become 1 over pi into minus pi squared. Now, how would minus 1 to the power of n behave when n is even? This will be positive, right? Yeah, because minus 1 to the power of 2 is just 1. 1 times minus pi squared is minus pi squared. So you'll be having minus pi squared over n remaining. And then for the next one, if you put even number here in this bracket, minus 1 to the power of 2 is 1. 1 minus 1 is 0. So 0 times 2 over n cubed is 0. So that guy is gone. So what will be remaining here will then become, when pi cancel out pi here, this will be remaining minus pi over n. So this is when n is even. So sometimes it's just okay if you know this. So we've been dealing with this in previous examples. So the next one is when n is odd. This one will be bulky. When n is odd. All right, when n is odd. So this is 1 over pi into, if you should put 3 here, or 1, minus 1 to the power of 1 is minus 1. Minus 1 times this minus pi squared will be positive. So what will be left here will become pi pi squared over n. Pi squared over n. Now for this very part, let's deal with this bracket. If we should put 1 here, minus 1 to the power of 1 is minus 1. So minus 1 is minus 2. That minus 2 will come and times this very 2 to give us minus 4 over n cubed. Minus 4 over n cubed. So this one, there's really no way for us to simplify this apart from saying that this is n and this is n cubed, right? This is n. You know what? Oh, hold on. I want to do something. Here's what I want to do. I know that when putting this expression into Fourier series, I need to factorize the constant out. So since this is n cubed, I'm trying my best to see how I can factorize out the constant. The n cubed, of course. This is a bulky one. It's a bulky one. But let's see. Okay. Let me see if there's a way. Let me see if there's a way to bring out the n cubed. So this is 1 over pi. And then, if I should multiply by n cubed, this will be n cubed over n cubed. I'm trying to do something here. This is n cubed over n cubed into, so n cubed over n cubed times pi squared over n, and then minus n cubed over n cubed times 4 over n cubed. Okay, that's what I'm trying to do. Let's see. I'm trying to do something. Okay, so if I should do this, let me bring out 1 over n cubed. So this 1 over n cubed pi. Yeah, this 1 over n cubed pi. So what will be remaining will become n cubed times pi squared over n. I brought out the over n cubed. I brought out this over n cubed, so I brought it out. And then minus, I'm bringing out this over n cubed too. So this will be n cubed times 4 over n cubed. Okay, so n cubed, we cancel out n cubed. All right, so n cubed, we cancel out n cubed. So this is 1 over n cubed pi. The one will be left here will then become n squared pi squared and then minus 4. Did this really make it better or did this make it much more complicated? Because I still have my n here. So what I have to do is to just open up my brackets. Just open up the brackets. I'm sorry about the time wasted for this, but let's just open up our brackets. Let's open up this. Since this was our expression before, let's just open up our brackets. So I'm just going to repeat that. 1 over pi into pi squared over n minus 4 over n cubed. So let me just bring this out. Let's just bring it out. So 1 over pi times this. The pi here, we cancel this pi. So this will be pi over n minus 1 times 4 is 4. Pi times this will give me pi n cubed. This is really, 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 really tedious. Let's leave that. Let's proceed. So any of these two will be used. So I'm going to put my b sub n. I was trying my best to see I can simplify the expression. So this is b sub n equal 1 over pi into, we have pi squared over n minus 4 over n cubed. So this is when n is even. Do I have space to write it? Yeah, let me just, even or odd. This is when n is odd. Then b sub n is equal to minus pi over n when n is odd. All right. So let us proceed. Let me wipe this out. Oof, yeah. Okay. Okay, so the Fourier series expansion formula is f of x equal a naught over 2 plus the sum from n equal to 1 to infinity of a sub n cos nx plus the sum from n equal to 1 to infinity of b sub n sin nx. Like I said, this is a lot. This very problem is a lot. Okay, so let us put in our numbers if we wish. Let's put in our numbers. So this is f of x equal a naught. A naught is pi squared over 3, right? So if you divide it by 2 again, it's already divided by 3. So if you divide by 2, that will be over 6. So this means we'll have pi squared over 6 plus the sum from n equal to 1 to infinity. And this expression here, a sub n, is 2. So we'll have 2 into minus 1 to the power of n over n squared. So this one, it doesn't matter if it's even or odd. That's just what we have. Cosine of nx. And then plus. Now this one, we notice that sometimes it's even, sometimes it's odd. How did I write odd twice? What is wrong with me? This one is even, please. This one is even. So let's start with the one when it's odd. So this will be the sum from n equal to 1 to infinity. When it's odd, we have 1 over pi, then pi squared divided by n minus 4 divided by n cubed. And then this will be sine nx. That's sine nx. Now, the next one is when it's even. So I think I should kind of put odd here. Yeah, so you kind of remember. And then when it's even, this will be plus the sum from n equal to 1 to infinity. This is even. Let me just put e there. So b sub n is minus pi over n. So that's minus pi over n. And then we have sine nx. So like as you can see, this is actually very, very bulky. Very, very, very bulky. Yeah, very, very bulky. So next, let us put in, you can decide to put in some numbers. You can decide to put in some numbers. Or you could do what I previously do. If n is odd here, you must always pick the odd numbers. You must always pick the odd numbers. Do not make a mistake of picking an even number. But like I said earlier, there's a way to avoid this. If you replace all the n with 2n minus 1, it means you'll be picking the odd numbers only. You will only be getting odd numbers. Then if you replace n with 2n, you will only be getting the even numbers. You will only be getting even numbers. So there are different ways to do this. If a equation says in terms of n, what is our Fourier series? So let me rewrite this because your graphing calculator does not understand that you're writing odd here. Does not understand that you're writing odd here. When you're writing your summation in your calculator, there's no such thing as there will be n equal to 1, then under it you now put odd, or beside it you now put odd. So how does this our function calculator or graphing calculator know that this thing would always be odd, or how does it always produce an odd result? So what we have to do is to put in that. So f of x is equal pi squared over 6 plus, this one remains the same. But before then, the 2 here is a constant, right? This 2 is a constant, so bring it out. This is 2. The sum from n equal to 1 to infinity. What will be remaining is minus 1 to the power of n over n squared cos nx. Now, 1 over pi here is a constant, so bring it out. So this is plus 1 over pi, the sum from n equal to 1 to infinity of this bracket here. So this is pi squared divided by, now since this is odd, all of the n, replace it with 2n minus 1. So this will be 2n minus 1 minus 4 divided by 2n minus 1 cubed. And then sine, the n here will be 2n minus 1, and then you put your x. Now for this next one, the constant here is minus pi. Minus pi is the constant. So this will be minus pi with the sum from n equal to 1 to infinity. Now, if you should bring out the minus pi, it means 1 over n will be what's remaining. This is 1 over n. But the thing is, this part is even, right? So the only way for us to be getting even result is to multiply by 2. So this is 2n sine 2nx. Beautiful. Yeah. So this is all we have. So in terms of n, this will be our answer. In terms of n, this will be our answer. That will be our answer. But let us write some terms. Let us write some terms in the Fourier series. Let us write some terms in our Fourier series. Okay, now you can decide to use either this or this to write your terms in the Fourier series. So f of x is equal, yeah, that shouldn't be happening. So this is pi squared over 6 plus, let me write, yeah, whenever you're using lights. So this is pi squared over 6, then plus, this is 2, and let's write some terms here. So let n equal to 1. Minus 1 to the power of 1 is minus 1, right? So let me just open this bracket up. Minus 1 to the power of 1 is minus 1. So this will be minus 1. Then n squared is what? N is 1 again. So minus 1 to the power of 1 divided by 1 squared. So everything here will be minus 1. Then cos n is 1. So this is minus cos x. You can decide to put 1, but you know the 1 is not really relevant. So that's why that's minus cos x. The next one, n will be 2. Minus 1 squared is plus. So this is plus 1 over. When you put in 2 here, 2 squared is 4. Then this will be cos 2x. That will be cos 2x. Okay. All right, let's proceed. Now, next number you want to put here is 3. Next number you want to put is 3. So we're going to be having cos 3x. So that's going to become minus 1 to the power of 3. So the next thing we want to do is to put in 3. So minus 1 to the power of 3, that's minus 1 over 9. Let me explain. Minus 1 cubed is minus 1. Then 3 squared is 9, because anywhere we see n, we're putting 3. That's minus 1 over 9. And then this will be cos 3x. That's what we have, cos 3x. Okay, let's proceed. Let's proceed. Okay. Next one. Let's put in 4. Minus 1 to the power of 4 is positive. So this is plus 1 over 4 squared. That's 16 cos 4x. But you can't go on to infinity, so you say plus, just like that. You can't really go on to infinity, so you do that. That's what you do. And then plus, this guy will be bulky. This guy will be bulky. So this is 1 over pi, then open up a bracket. When you open up a bracket, anywhere you see n, you're going to be putting 1. Or you could use this very formula here. Anywhere you see n, you're going to be putting odd numbers. So let's start. This will be pi squared over, the first odd number is 1. So just put 1 here. What this means is your expression will just be pi squared minus 4 sine x. Because anywhere you see x, you're just putting 1. So when you put in 1, anything over 1 is that same thing. So that's fine. Then the next one, we're going to say plus. The next odd number is 2. Next odd number is 2. So let's put in 2 here. This will then become pi squared over 2. That's pi squared over 2. And then minus, when you put in 2 here, 2 cubed is 8. So what is 4 over 8? That's half. That's minus 1 over 2. Hold on. You see, this is why I hate using this approach. I went to go and put an even number when everything was supposed to be odd. This is why I don't like using this. I just prefer using this one. Because if I use this one, every single thing will be odd. Sorry about that. This is 3. N was supposed to be 3 because the next odd number is 3. This is pi squared over n. So that's pi squared over 3. And then n is 9. So this is 4 over 9. Not even 9, 27. Because if you say n is 3, 3 cubed is 27. So that's 4 over 27. And then sine 3x. I'm going to end at 5. So the next odd number is 5. So this will become pi squared over 5. Pi squared over 5. And then minus 4 over 5 cubed is 125. 5 cubed is 125. And then sine 5x. And then I'm going to close this up. Oh, sorry, let me put the dots, when it continues just like that. And then the last one, when it's even. Oh, there's a minus. There's a minus. When you factorize this, so this will become minus pi. And then what we'll do next is, anywhere we see n, I'm going to use this one, please. Since it's even, I'm going to just use this one. And this one is easy to know. So this will be 1 over 2 sine 2x plus 1 over 4 sine 4x plus 1 over 6 sine 6x, and just like that. I think that one is much more easy to know when you put in all your even guys. That's what you have. And this is the Fourier series expansion. This is the Fourier series expansion of the function. So that's really a lot. That's really a lot. Yeah, it is a lot. Okay, now we're told that we should use the Fourier series to show that this is equal to pi squared over 12. We're asked to show that this is equal to pi squared over 12. Now the good thing about this whole expression is this. When you have something like this, please listen up. When you have something like this, what you're expected to do is to say let x be something. What you're expected to do is x has to be some number. So there should be a number that you're going to use to prove this. In some exams, they will say let s equal to pi. Hence, show that this is correct. Let s equal to 0. Hence, show that this is correct. Let s equal to whatever. But in this case, we're not given. So we have to think what x should be. To start with, if you notice, this our expression here for the Fourier series is not having this pi squared over 3, 4 over 27. It's not having these guys. Basically, this is what our answer is. This is the minus 1 here. There's a 1 here. This is the 1 over 4. This is the 1 over 9. This is 1 over 16. So the answer we need is in between here. The answer we need is right in between this very place. But for some reason, we must eliminate the sign. Now remember that sine will be eliminated. Sine will be eliminated when s is 0. Because if s is 0, sine 0 is 0. If s is 0, sine 0 is 0. So all of these guys, sine 0 would eliminate all the zeros. Also, if you put x as pi here, because every single thing here is n pi, so sine n pi is also 0. So all of the sign will still be eliminated because the sign of some number, any number at all, not really any number, any integer multiplied by pi would also give me 0. So which of them should I pick? Should I say let x be 0 or let s be pi? That's the tricky part. So what do I do? Should I say let it be 0 or let it be pi? Now I'm going to say let it be pi. Now listen up and let me tell you why. There are so many reasons on why it should be pi and not why it should be 0 and not pi. Now sometimes you need to look at your expression very well to be able to ascertain that it should be 0. Now let's say it's 0. Put in 0 here. Cos 0 is 1, right? Cos 0 is 1. So this will become minus 1 plus 1 over 4. So if you notice, the sign is alternating with this. But if you pick your pi squared over 6 here, your pi squared over 6 come here will now make it negative. So the minus here will multiply this minus. Let me just show you what's going on so we don't stress ourselves. So let s equal to 0. So this will become f of 0 equal to pi squared over 6 plus 2 into, remember that cos 0 is 1. So since we're putting in 0, cos 0 is 1. So this will be minus 1. And this will be plus 1 over 4 because cos 2x, 2 times 0 is 0. Cos 0 is 1. 1 times 1 over 4 is 1 over 4. And this is minus 1 over 9 because this is just 1 times this. And this is plus 1 over 16 because cos 4 times 0 is 0. So cos 0 is 1. 1 times 1 over 16 is 1 over 16. Yep. Now this other part will just be 0 because sine 0 is 0. So let's not stress ourselves to write it. So that's gone. Now what is f of 0? Now what is f of 0? Now first of all, the number we used here was 0, right? So if you come here, 0 squared is what? 0. Please take note, you know you could use any of them. Since this is saying that f of s is 0, so you could put f of 0. F of 0 will give us 0. Or you could say 0 squared is 0. So at this point, it's not really, I don't think we need to use any midpoint theorem here or anything. So this is all we just have. So f of 0 will just be 0 equal to pi squared over 6. Now if you notice, since this is minus plus, just like that, but what we need is plus because the one right here is plus. So this is plus, minus, plus. We need it to start from plus. What we simply have to do is to factorize the minus outside. Bring out this minus. Once you bring out a minus, every single thing here, the sign will not change. So this is minus 2. When you do this, this will then become 1 minus 1 over 4 plus 1 over 9 minus 1 over 16. It's looking much more better. Look at it. When you expand, 2 times minus 1 is what? Minus 2. Is it the same with this one? Yes. Minus 2 times 1 is what? Minus 2. Let's try the second one. 2 times 1 over 4 is what? 2 times, they are both positives. These two guys are both positives. Let's try it here. Minus 2 times minus 1 over 4. The minus sign is, the minus will give us what? Plus. So the sign is still positive. So this and this are still the same. They are still the same. So right now, this pi over 6, the pi squared over 6, let me take it to this other side. So this will be pi squared over 6 with a negative sign because this will then become negative. Equal to what? Minus 2. Then we have 1 minus 1 over 4 plus 1 over 9 minus 1 over 16 and just like that. Okay, so what I'm going to do next is to divide by the minus 2. So divide both sides by the minus 2 because as you can see, there's really no number here. So let's divide by this minus 2. Or you could say multiply both sides by minus half. There are two ways to do it. Either you say divide by minus 2, multiply by minus half. It's still the same because minus half is same as 1 over minus 2. So it's the same thing as dividing by minus 2. So multiply by minus half. So minus half times minus pi squared over 6 is equal minus half times minus 2 into 1 minus 1 over 4 plus 1 over 9 minus 1 over 16, just like that. So minus will take care of minus. 1 times pi squared is pi squared over 2 times 6 is 12 equal to 2. We cancel out 2. These 2 minus will be positive. So what will be remaining will just be the bracket 1 minus 1 over 4 plus 1 over 9 minus 1 over 16 and just like that. So this, ladies and gentlemen, concludes the solution to this very problem. So this will be the answer to our question. I believe you understood every single thing we've done. So this will be all for this very video. I'll see you in the next one. Bye.